Okay, so let's start. Welcome everyone to the next part of our webinar series about getting started with Kubermatic Kubernetes Platform. My name is Caroline and I'm very happy to see that so many of you are joining today to learn more about how to install Kubermatic Kubernetes Platform on an existing Kubernetes cluster. Our speakers for today's webinar are Yusuf Esrak and Jacopo Rossu, who both work as software engineers at Kubermatic and who will be explaining you today how to set up Kubermatic master and seeds, including the required infrastructure, how to deploy user cluster, and then they will be showing you a demo about setting up Kubermatic Kubernetes Platform from scratch on AWS. If you have any questions during the presentation, please type them into the Q&A chat window below so that we either can answer them straight away or in the Q&A session right after the talk. In the chat, you'll also find some links we just posted, just in case you want to follow or if you want to try something during the presentation, you'll find them in the chat and you can use them right there. And yeah, so just one last thing to add from my side before I hand over to Yusuf. In case you need to drop out earlier, no worries. We are recording the session and we will send out the replay in the coming days. So yeah, just one last thing. I hope you'll enjoy it, have fun, and yeah, Yusuf, now it's your turn.
So thank you, Caroline, for the introduction. So as Caroline said, I'm Yusuf, I'm a software engineer with Kubermatic, and with me there is Jacopo, he's a senior software engineer. We both work in the same team, so let's call it the backend team or distributed system team for the Kubermatic Kubernetes Platform. And today we will focus on installing Kubermatic CE edition, so the community edition, the free one. We are also assuming you have a working Kubernetes cluster. If you don't have one, you can check our previous webinar, the Kube1 webinar, where you can deploy very quickly, in a matter of minutes actually, a Kubernetes cluster from scratch. We will also be focusing on the practical side, I would say, more than the theory. So the demo part, just to show you how to install from A to Z, the Kubermatic and have a working user cluster for Kubermatic. And basically, we will, again, focus on the main components of Kubermatic. We won't go with the add-ons and everything. Those are given by the documentation if you want to deep dive, I would say. The goal here is to have a nice and clean working Kubermatic installation. So with that said, I will start with the theory part and with the architecture. So here what we have is what I would call the typical Kubermatic installation or architecture, where you have master and seed cluster running on the same Kubernetes cluster and a couple of different customer clusters that you see below, or user clusters like we call them. So what are those components? There are lots of things, but actually it's pretty easy. So if we start with the master one, so what we mean by master cluster, it's running on a Kubernetes cluster. It's running the Kubermatic namespace component. So those are the main required components for Kubermatic: the dashboard, the Kubermatic API, and the Kubermatic controller manager. And then we have the seed clusters. And here, the seed clusters are basically the one that you see below, the customer cluster, one namespace, etc. So those ones are running the control plane of the Kubernetes customer cluster. So here you will have all the control plane from Kubernetes, so API server, scheduler, etc., etcd, Prometheus for the logging, OpenVPN server, machine controller, and I will go back with the OpenVPN server and OpenVPN client in a minute in the expose strategy, and I will give some detail about those a little bit later. So this is, again, the typical architecture, typical deployment. In the case you have a big infrastructure, lots of customers, you're deploying Kubermatic, I would say, let's say in a couple of continents, you can decouple the master seed cluster and have what we would call a large scale Deployment. Here, the master cluster will be running somewhere, wherever you like, actually. So you'll have the dashboard, API, and controller manager. And then each seed will be running somewhere. And you can make it run, for example, as in the diagram, one in Europe, one in North America, another one in Asia. The goal here, the main goal, I would say, is to reduce latency between the customer cluster, I mean the kube system pods in the namespace, and the control plane. So this won't, when I say latency, I'm not speaking about your end application latencies. I'm speaking about the control plane latencies. So yes, so to give you an example of those seed cluster and the customer clusters, I would say not an example, but the good thing about Kubermatic is you are free basically to deploy wherever you like. So you can have a seed cluster running in AWS data center in Europe, and customer cluster running on Microsoft Azure, and another customer cluster running on DigitalOcean, another one running somewhere else. And then you have all your apps inside those Kubernetes clusters, speaking with the seed cluster that is related to them. So now the question is how those customer clusters or user clusters speak with their control plane on the seed side. This is done with the expose strategy. So what we call expose strategy with Kubermatic is, to put it really simply, is how we access the control plane of the user clusters. So there is a link for the documentation. If you want more details, we have currently 3 expose strategies. One is called node-port, the other one global load balancer, and the other one load balancer per user cluster. I will just speak about the global load balancer one because this is a default one, and this is the one that will be used today for the demo and for my explanation. So the global load balancer one is basically you have one load balancer for your seed cluster. One load balancer, when I say one load balancer, it could be a cloud provider load balancer, say AWS Elastic load balancers, or it could be an on-premise load balancer. I mean, if you have an F5 load balancer, this is also good. Any load balancer would do. And then the global load balancer will have multiple listeners. So the listeners, there will be 2 listeners per user cluster. Why 2 listeners? Because we are opening a listener for API server, but also for the OpenVPN. So say you have 10 user clusters, you will have for one load balancer, 20 listeners. So that's how you can calculate it. And about the OpenVPN, I spoke about OpenVPN. So just to make things a little bit clearer, the OpenVPN one, we're using it basically for 2 main reasons. The first one is to encrypt the traffic between the user clusters and the seed side, the control planes. So the traffic for more security, to put it simply. And the second reason is for the routing of private IP addresses. So I won't deep dive into this because this is not the goal of this talk. But yeah, this is why we're using OpenVPN with the API server. Also, we are working, well, actually me and Jacopo, so we're working on a new expose strategy that will be using one load balancer. So same one as the global load balancer. The only difference is that we won't be using randomly generated port. Right now we're using randomly chosen ports, I would say, from the node port range. So from 30,000 till 32,000 something, I don't remember the exact number. So we'll just use 2 listeners for the whole seed clusters. So you just have 2 listeners, even if you have 600 customer cluster, for example, it will stay the same. If you're interested into the details of this, you can just go to the GitHub, Kubermatic GitHub, into the proposal, and we have a proposal that is written here about this part. So regarding this webinar and the master installation, we will use 2 links, and I think they're in the chat. If you can't see them, just leave a message on the chat. So the first one is a GitHub repo. This one is, to put it really simply, you just have a script, and this script, we created it for the demo. It's not needed, but it makes it easier and more smooth to generate basically 3 files: the Kubermatic one, the seed one, the values one, YAML files that I use to install Kubermatic. And I will leave it to Jacopo to give details and show you how this is used. But also we'll be also following the official documentation. So 2.14, if you go to the link, we'll simply be using the install Kubermatic CE one and add seed cluster for CE. So those 2 links. And again, for the demo part, Jacopo will speak about all the stuff. So first thing first, I will go through those steps without going into details, just to give you an overview of how to install this. So for the master installation, again, you can use a generate script that will read the folder, the kubeconfig, which URL you want to use to access your Kubermatic dashboard, and if you want it to be signed by a well-known certificate authority, or you can simply follow the documentation. Again, I mean, you can those files can be generated manually by hand, no problem. You can do that. So once this is done, we have 5 that are generated, the one I showed you before, and we need to deploy the storage class for the persistent volumes and set up Tiller for the Helm charts installation. And for the main components, the required components, I would say, for the master cluster to work in Kubermatic, you just need 4 Helm charts. So the Nginx ingress controller chart, and this one is used to access the Kubermatic dashboard. You also have the cert manager one, which is responsible for the certificates generation, etc., etc. And the OAuth one, responsible for everything related to authorization, authentication, login, and everything. Say when you want to access your Kubermatic dashboard. And finally, the Kubermatic operator chart. This one is responsible to, it will deploy all the Kubermatic pods and components required to make Kubermatic work. So once you have installed all those, there is one thing that needs to be done from DNS point of view, and this is needed to access the Kubermatic dashboard. Obviously, this is not related directly to Kubermatic. It's just normal routing and I would say exposure of application. So you can use any DNS provider. In our case, we're using AWS. You could be using Google Cloud DNS or whatever, OVH. Who knows what you're using, internal DNS, doesn't really matter. What matters is just the value of the A record. So to get the right external IP that has been assigned by the provider, by your load balancer, just issue a kubectl get services on the Nginx ingress controller namespace. And this value, you populate it with the record name. And here I put, to be honest, I put I think it's a randomly generated IP that I put there. But anyway, you populate with the right IP. And once this is done, then you can access the Kubermatic login and using the URL that you have defined in the beginning of the installation process. For the demo purposes and for the lab, with the tarball, we have put a static username and password. If you use this in production, please obviously change it. I mean, you don't want kubermatic@example.com and password as a password. Obviously, you have lots of other login methods, say like if you want to log in with SAML and using GitHub or your Google accounts, this is all possible and it is all detained to the documentation. But again, we are just focusing on having a working installation and a working Kubermatic. So when the master installation is done, we can install the seed. So to install the seed, it's very simple. There's just one seed file that is generated with a script, or then you can create. What do you have in the seed file? In short, you tell in the seed file on which data center and cloud provider or provider without the cloud you want to deploy your worker node, your user clusters, basically. So once you generate this file, you can just apply it using a kubectl apply, and the Kubermatic operator that we installed earlier will install the required components. Once this is done, same as with the master part, you have to update a DNS record. So there will be a node proxy pods that are deployed, and those one will be basically or are created basically to load balance the user cluster traffic to the right control plane. Okay, so we create a new load balancer, And this load balance external IP will need to be populated or put into the DNS records. And this DNS record will be of the form, it's a wildcard DNS form basically. So a star.seedname.kubermatic URL. So in the case of the C edition, we just have one seed name and it must be named Kubermatic. So it will be star.kubermatic.kubermatic URL. When I say Kubermatic URL, it's the URL you put. It could be, I don't know, blah, blah.mywebsite.com, whatever the URL is. Just the beginning, make sure it's a star.kubermatic, and that's it. Once you have created this, we can move to the user cluster installation. So the user cluster installation, this is after you log in to Kubermatic. It's pretty straightforward. Just click to add project. You name your project. You have now clusters. You add a cluster. Name your cluster. Choose a Kubernetes version of your cluster. Select the cloud providers and the data center. Well, in my case, in my seed file, when I took the screenshots, I just populated with AWS as a provider, and I put Frankfurt as my, I would say, availability zone or data center for AWS. So that's why I have just this one choice, but obviously you can have multiple providers and multiple data centers. In the settings, this is what I like about this dashboard, to be honest. It's very simple, and even for the settings, you just have to put two things. I mean, this is AWS. I mean, it's related to AWS because I'm choosing an AWS cloud provider. If you don't have a presets available, and Jacopo will probably do the demo with a preset. So this is, you can see the 2 version. You just push your AWS access key ID and AWS secret access key here, and everything will be populated automatically. Once I say everything, all the subnet ID and availability zone, route table, VPC. So here we can change the subnet, the ID and availability zone, and it will automatically give you the choices from your AWS account, which is very handy, and you don't have to do some back and forth to get the right information. Just add your public SSH keys, choose your OS, public IP if you want, or if you don't want, and that's it. You have a summary window with all your choices. You can then create your cluster, and there we go. After 1, 2, or maybe 2 minutes, you should have same kind of window as I have right now, with node deployments, which are basically the user clusters. Here I just have one replica running on EU Central 1C, and that's it. With this arrow, you download your kubeconfig file of the new Kubernetes clusters, and you are ready to go to deploy your applications. And I think that's it for my side, and I will give the hand to Jacopo to do the demo. So one sec.
Thank you, Youssef. I hope you're enjoying the webinar so far. So I saw we have a question from Naveen, but if you don't mind, I will take it at the end. So let me share my screen. Oh. Okay. Can you see it? Please react if you cannot see it. So what we will do is to try to follow as strictly as we can the installer documentation, so that we can show you how to install it, how you would install a Kubermatic platform for demonstration purposes. So the requirements are a Kubernetes cluster that will be used to run the master and the seed parts, as explained by Youssef, kubectl, and Helm. For the moment, we are just supporting Helm version 2. We are almost ready for Helm 3, but the documentation at least is not ready yet. So we will stick to Helm 2. So let's start. So first thing, we will download the tarball that contains the Helm charts that we will use during the installation. You can safely copy and paste the commands you find in the documentation. As you can see now, we have this charts directory and the example folder. The example folder contains the 3 configuration files that we need to install Kubermatic. So we have a values.yaml file that contains the values for the Helm charts. And we have 2 manifests, seed and Kubermatic, that are basically resources specific of Kubermatic that will be handled by the Kubermatic operator. So let's continue. We need to create a storage class because, for instance, etcd requires persistent volumes, of course. So let's create it. So here we are. The storage class is created. Now we will need, as we are using Helm 2, we need to install Tiller. That is the server part of Helm. Again, I'm just copying and pasting the commands you can find here. At this point, we need to prepare the values file. Let me put it bigger. As I showed you, we have some example files in the tarball you can find for each release of Kubermatic. I prepared, me and Youssef prepared a script for the demo that will help us basically to replace the placeholders with the proper values according to our environment. I didn't mention it, but we will install it on AWS. This is just an arbitrary choice. So I will run this command that runs the script I mentioned. Okay, at this point, I have at the root of my working directory the seed.yaml, values.yaml, and kubermatic.yaml. That are the configuration files I mentioned before. So at this point, I can start applying the Helm charts. I will start from the Nginx ingress controller that is used to expose, for instance, the dashboard of Kubermatic. So it's created. Second, I will create a cert manager that is used to create the certificates required by Kubermatic. You can also decide to provide yourself the certificates, but this is a very handy way. It's based on Let's Encrypt service to generate the certificate. So let's create it. Let's wait, okay. Let's just wait for cert manager to be up and running because the next chart will require cert manager to be installed correctly. Okay. So the next chart is auth. It will install the DEX service for federation of authentication. You can plug it with your identity provider of choice. That can be, I don't know, LDAP or some public service like GitHub, GitLab, like Google or whatever. So okay, so here we are. We applied the first set of charts that we need. Here we have commands to verify that everything is being deployed correctly. Next, we need to start with the DNS configuration. So we have this service of type load balancer. In AWS, it gives not an IP, but a host name, but is the same. So now I will configure an A record on AWS Route 53, pointing to this host name. So I have already configured hosted zone. I configure an A record of type simple routing, define simple record, and we will call it Kubermatic at webinar.dev. As it's backed by a classic load balancer, I choose this option. It's in Paris region. Okay, this one, up, and let's create it. Okay, now we have our A record. Let's see if the DNS configuration has been already applied. We can use dig. Okay, let's see if it matches the IPs that we get by resolving this host name. Yes, it's okay. The order doesn't matter. So far so good. We can progress with the installation. So next step is to create the CRDs that are required by the Kubermatic operator. And not only by Kubermatic. Yeah, I could just copy paste everything up. Okay, as you see, a bunch of CRDs have been created, including the seed, that is the one we already met before, and the Kubermatic configuration. So next step is to create, is to deploy the Kubermatic operator also using Helm. Okay, up. Let's see what's happening. We can see that the Kubermatic operator pod is creating. So it will take some time because the image is quite heavy. Let's wait a moment. And okay, it's running. Next step is to apply the Kubermatic configuration manifest. That is the one we generated using the script I mentioned before. Okay, it's created. We can watch again in Kubernetes namespace and see what happens. We can see that there are a bunch of components that have been spawned by the operator. So we have 2 API pods, a master controller manager, and 2 UI pods. So this basically concludes the first part of the setup. Now we have a Kubernetes master up and running. And yeah, the documentation suggests us to take a break. As I said, that we will follow it. We will take 1 second break. Okay, can continue. And let's go to the seed cluster configuration. Okay, the seed cluster is basically the one that will host the control plane of the user clusters. In our case, it's co-located with the master cluster. It's the easiest setup. So it recommends to install some services to do the backup of etcd, because this is very important for a production grade deployment. But as we are installing it just for demonstration purposes, we will skip this. And we will go straight to the creation of the seed resource. As you can see, we are not just creating a seed resource, but also a secret that contains the kubeconfig that is used to access the seed cluster. In our case, master and seed cluster are co-located, so it will be the only kubeconfig we have. And here, yes, we will also we specify the list of data centers where will be allowed to create the user clusters. But let's create it. It will be more clear when I will show you the API. Okay, the secret and the seed resource have been created. Now let's see what's going on behind the seed. So we see that there is another controller that has been created by the operator. This is the seed controller manager. And we have also the node port proxy component that has been deployed. This is the one that is responsible for exposing the control plane to the worker nodes, as Youssef explained during the theoric part. So let's wait for the seed controller manager to be up and running. Okay. And we're almost done. We just need to complete the DNS configuration. So we have to get, there is another service of type load balancer that has been created for the node port proxy. So I will do something similar to what I did before. I will create another A record. But this time it will be, not here. This time it will be a wildcard record, because it's the one that is used for all the user clusters of this seed. Unfortunately, I'm repeating Kubermatic because the seed name in this case is Kubermatic, but with a Enterprise Edition installation, normally you have one seed per region, so you can imagine that you will have a more meaningful name for each seed, like, I don't know, Europe West at .kubermatic.yourdomain.com or whatever. So it's the same type of record as before, classic load balancer. The region is the same. And let's put it. Define, create record. So similarly to what I did before, we can verify that the DNS configuration has been applied. So dig, you can put, it's a wildcard record, so we can put whatever. I put me, but doesn't really matter. So we get this. Let's see if it is consistent with what we get resolving this host name. I would say yes. So, okay, the DNS configuration is completed. And at this point, we can try to access the Kubernetes dashboard. The Kubernetes installation is completed. Sorry. Okay, so we can, let me put this bigger. This is the Kubernetes UI, so we have to sign in. We configure the static user, but as I said, we are deploying DEX, so you can plug it with your LDAP or whatever identity provider you prefer. Okay, so as Youssef showed in the slides, first of all, we have to create a project that is a kind of logical grouping of user clusters. Okay, the test project is ready. Now we can create our first user cluster. So we can generate a random name. They have funny names normally. We can select the Kubernetes version. Here I picked the default, that is 117.9. We only defined AWS as a provider, but we support much more than this. You can find the exhaustive list in our documentation. I also set a single data center that is in the Frankfurt zone of AWS. Yeah, I forgot one thing, because here I don't want to type the passwords manually. So I will create another object that is called preset that basically contains the credentials. You can also find in Kubernetes documentation how to write a preset resource. Now, unfortunately, I have to restart from here, but it's not a big deal. AWS, Frankfurt, Lutzi. As you see here, I cannot put passwords any longer. I generate a name for the nodes. We will have we are using the Kubernetes cluster API, and we have a component that is called machine controller that takes care of creating, of provisioning the worker nodes. And this is the name that will be given to the machine deployment. So a set of worker nodes. So I pick the default values. I will be using Ubuntu. You can see here the other OS we currently support. And that's it. Now we have just to wait for the control plane components to be up and running. And when they will be ready, node deployment, that is the same as machine deployment, actually will be created. So we can wait a moment. You can also monitor the progress using the command line tool. So we have a namespace for each user cluster. This is the one that has been created for our user cluster. We can see that there are a bunch of components that are still initializing, but it is running, almost running. We have still EC2 that is not in ready state. So I think it won't take much longer. And when it will be ready, I will be enabled to download the kubeconfig in order to access this user cluster. Those are just transient issues. You should not be worried. Okay, now etcd is running, so everything should converge quickly. Yeah, here we go. You see, I can now download. Yeah, I would use curl. And I save the kubeconfig in this file user.kubeconfig. Okay, now I can export the kubeconfig environment variable. Okay, here we are. As you see, the pods, it's almost empty. There are only the system pods that are still pending because the worker nodes are not ready yet. Let me make it full screen. We can monitor the progress of the creation of the worker nodes here. So it will take some time because it has to create the VM, provision it, and it takes a couple of minutes. But if someone of you have experience with installation of Kubernetes, would understand that this is quite impressive how fast this process is. So yeah, we can wait another. What does here in the UI, you can also see the events that are dispatched by the controllers. It's now installing the CNI plugin. This means that is almost ready. And it will be all green in a few seconds. Let's see if we have the node. As you can see, it's not ready yet because the CNI is still initializing. But as you can see, the particularity is that we don't have any master nodes. because the control plane is hosted in the seed cluster, as we explained before. So we can just see the worker nodes, and now it's ready. So this concludes the demo. So we, in I would say 20 minutes or something like that, we managed to deploy a Kubermatic Kubernetes platform and also to create our first user cluster. So I think it's time for questions. So let me check. I see no open questions, but in the chat I saw a question before. Let me check.
It was here. It was, may I know the advantage of Kubermatic?
Okay, so the question was, which is the advantage of Kubermatic? So yeah, it's a question that would require quite a long response, but let's see a few advantages. So basically, traditionally, when you create a Kubernetes platform, you are deploying a few VMs that will be used to host the control plane, and then another set of VMs or bare metal machine that host the worker nodes. So this approach requires some effort for managing the control plane part, and also some resources for the VMs that host the control plane. And you can imagine that handling a very large Kubernetes cluster requires a lot of effort and human resources. Kubermatic helps to automate some operations and provides new models for scaling, because what you do traditionally in a Kubernetes platform is that you add worker nodes, and at a given point you hit some limitation and operation costs explode. There are examples of Kubernetes clusters that arrive up to thousands of nodes, I think like 2,000-3,000, but those are really pushing to the limits and require some hardware very powerful for hosting the control plane. With Kubermatic, you can have another dimension for scaling. For instance, we have customers that are running hundreds of user clusters on a single Kubermatic installation. And these with a few nodes for each user cluster. So this helps to do some segregation, because you can imagine that having workloads running in different workloads running in the same Kubernetes cluster is not as having a dedicated Kubernetes cluster for each type of a workload or customer. I mean, you can use this dimension in the way it better suits you. Another thing is that, for instance, as we support many cloud providers, and also we support in-premise deployment, because, for instance, we support VMware, vSphere, and OpenStack. You can imagine that with the Kubermatic, it's quite easy to set up an hybrid cloud solution. So you can, for instance, decide if you have some sensitive workload, you can run it in-premise, and you can spawn very easily dedicated clusters in the cloud for other kind of workloads. I don't know if Youssef, you want to add something?
No, I think you summarized it quite nicely.
Good.
But there came up another question. Master cluster will manage the seed clusters.
Yes, exactly. Basically, the master cluster is the cluster that will be managing the seed clusters in case you have many. When you add seed clusters, you have to create a seed resource on the master cluster, and the Kubernetes operator that will be running on the master cluster will take care of doing the necessary configuration and provide and basically set up the seed cluster. Yeah, that's exact.
Are there any further questions? Okay, it seems not. Just in case, if you still should have some questions or any topics you would like to discuss with us, you can send us an email to marketing@kubermatic.com, or you can directly reach out to Youssef or Jacopo, and then you can just go through your questions with them. Just very short on our behalf now, our next webinar, Kubernetes 101 Part 5 about exposing apps, will take place on August the 12th at 5 p.m. So I'd like to invite you all warmly to join us, and would be great to see many of you there as well. Thank you very much for joining today. I hope you enjoyed it. And we are always happy to receive some more followers on Twitter and our social media accounts, and about some new GitHub stars for our open source projects. So feel free to support us. Yeah, thanks again, and have a nice evening, and see you soon next time.
Thank you guys. Bye-bye.
Thank you guys. Hope you
Bye.
enjoyed.